Okay, here's the first example for this lesson. So fill in the following table for the quadratic function shown and then graph it. So we're given the equation y equals x plus 2 squared minus 3. If we want to be able to label the vertex axis of symmetry and all of that, we should first get in the habit of figuring out what our a, h, and k values are. You don't see anything in front of here. So our a value, we know if we don't see anything, there is an invisible 1 there. So our a value is 1. Our h value is actually negative 2. Okay? Because if we plug negative 2 into x minus h squared, it would give us x plus 2. So our h value, whoops, I don't want to write that in highlighter. Our h value is negative 2. And our k value, k is right here. Our k value is negative 3. K equals negative 3. Good. Now we have everything we need to know in order to fill out this entire table. Our vertex is simply hk, which in this instance is negative 2, negative 3. Our axis of symmetry is x equals h, which in this case is x equals negative 2. Because we figured out our h value is negative 2. That's the vertical line that'll go through the vertex. Stretch or compression factor. So we figured out our a value was 1. So there is no stretch or compression. When we multiply something by 1, it's not going to stretch or compress. It's just going to stay the same. So we are going to answer a equals 1. Therefore, no stretch or compression. I'll just write a short form here, or compress. Okay. Direction of opening. We know because a is positive, it must open up. Values x may take. X can always take any real number for the parabolas we're going to work with in this unit. Any real number. Values y may take. So the parabola opens up, so we know it has a minimum value. Okay? And our minimum value is that y equals negative 3. The parabola will never, ever, ever go below negative 3. Okay? That's the vertex. That's the minimum point. The parabola on the y-axis will never go below negative 3. Okay? It can be equal to negative 3 or any number above negative 3, but it will never go below negative 3. So the values y may take are y greater than or equal to negative 3. We will, after we draw the parabola, I'll go back and explain that again, just so we make sure we consolidate that information right. Okay, so the next slide, we're going to graph this parabola. Once again, I chose x values surrounding what our h value was. So our h value is negative 2, so I put that in the middle. And then I chose 2 values to the left and 2 values to the right. And then we're going to plug all of those into our equation, and then figure out what our y values are going to be. If we plug all of those into our equation, we will get y values of, let's figure it out here quickly, y values of 1, negative 2, negative 3, negative 2, and 1. Okay? And you'll notice once again the y values are symmetrical on either side of the vertex. So here's the vertex, negative 2, comma negative 3. And the y values are symmetrical on either side. We have negative 2, 1, negative 2, 1. If we want to graph this parabola, we plot the vertex, which is at negative 2, negative 3. Let's go to the left this time. So we'll go to negative 3, and that's negative, for the x value of negative 3, y is negative 2. And then for the x value of negative 4, our y value is 1. And then we know the parabola is symmetrical. I'll put that little I'll draw the axis of symmetry on here. So our axis of symmetry, let's use this one here, goes, it's a vertical line through the vertex. So there's the oh, I curved it a little bit. Let's straighten that out. Oh. Let's try again. Axis of symmetry. Last try. Okay. There we go. Okay, there's our axis of symmetry. Vertical line through the vertex. So using the symmetrical properties of a parabola, we know the points to the right of the vertex are going to have the same y values as the points to the left. Okay, there's our parabola. Connect it with a smooth curve. Take your time doing it. Perfect. So there's the sketch of the graph of y equals x plus 2 squared minus 3. Okay, example 2. Let's once again figure out our a, h, and k values. Our a value, in this case, is negative 1 over 2. So I'll just jot that down. A is negative 1 over 2. Oh, forgot my negative sign. There it is. H value is positive 1. Because this is my h right here. Good. And then my k value is positive 8. K equals 8. So the vertex is hk. So that is 1, comma 8. That's not a very nice comma. It's a little better. Axis of symmetry is x equals h. And we know that h is equal to 1. So x equals 1 is our axis of symmetry. Stretch or compression? Yes. In this case, we do have an a value that is not 1, so it is going to be stretched or compressed. Our a value is negative 1 over 2. So a is negative 1 over 2. Ooh, that was not good. A. Let's try it again. A equals negative 1 over 2. Okay, so we have an a value that's between 0 and negative 1. We know that that causes a vertical compression. So vertical, I'm going to use short forms in here. Vertical compress by a factor of 1 over 2. Okay? When we're describing the vertical compression or even a stretch, we're not going to include the negative when we describe it by a factor of the a. The negative is only important for when we're describing the direction of the opening. Because it's negative, the a value, we know that the parabola is reflected in the x-axis. So that means it is now opening down. When a parabola opens down, we know that it has a maximum value. Okay? Values x may take, once again, it's any real number. Any real number. Values y may take, we know this parabola has a maximum value because it opens down. So the vertex is at 1, 8. So this parabola will never go above 8. Okay? The maximum value is y equals 8. So the parabola can have any y value under 8 or equal to 8, but it will never go above 8. So y has to be less than or equal to 8. If we want to sketch this parabola, we're going to choose x values around 1. Our h value, we remember h is equal to 1, so I'm going to put that in the middle. Now I'm going to choose about 2 values to the left, sequentially, so 0 and negative 1, and then the 2 values to the right are 2 and 3. If I plug all of those values into my equation here, so if I plug in negative 1 for x, I will get 6. If I plug in 0 for x, I will get 7.5. If I plug in 1 for x, I will get 8. If I plug in 2, because of the symmetrical properties of the parabola, we know it'll be 7.5. If I plug in 3, it'll be 6. Okay. So once again, so here is our vertex, 1, 8. I'll just highlight that nicely for us. That's our vertex. And if we look at the y values, you'll notice that they're symmetrical on either side of the vertex. Let's plot these points and sketch our parabola. Plot the vertex first. 1, 1, 2, 3, 4, 5, 6, 7, 8. Did I count that right? 1 over, then 1, 2, 3, 4, 5, 6, 7, 8 up. Good. Okay, let's go to the right this time. So we go, we go 2 to the right on the x-axis, and then 7.5 up. It will look like the point will be right there. If I go 3 to the right and then 6 up, point will be 1, 2, 3, 4, 5, right here, 6. There. I'll draw that little axis of symmetry again. I think that was helpful last time. Remember, the axis of symmetry is a vertical line going through the vertex. So we know this parabola is symmetrical. So the points to the left of the vertex are going to be at the same y values as the points to the right. And we know that this a value is between 0 and -1, so it's going to be compressed. So this parabola looks pretty wide here when I sketch the line through it. So we know vertical compression means that the parabola gets wider. Good. So there's the rough sketch of that parabola.